Can friction pull objects? Hi, this is Ashish Gourav, and I have done my B.Tech from IIT Kharagpur, and I have also taught physics, JEE physics in IIT-JEE for a long amount of time. Usually, when you have objects or items, whatever you would like to say these things, we think of friction as an impediment, as a struggle, as a hurdle, something which tries to stop the motion of objects. What is the reality, or what is the cause behind such perceptions which we have? Before we understand that, we need to really know that there is a way to classify friction into static and kinetic friction. Now, static friction operates when there is no slipping between the surfaces of two objects. Now, what do I mean by that? Let's say these are the two objects which you have. If I do it like this, there is a slipping, which means I will have a different kind of friction, not static friction. But let's say these two objects are here and I move them together, then there could be an existence of static friction. So you see, when there is no slipping between these two surfaces, you could have static friction. When there is slipping, you will have kinetic friction. Let me bring one more item. If I slide this object like this, there's a slipping friction, or I can say kinetic friction between this surface and this surface. What if I try to push it like this? You see that these two are moving together, which means there is a static friction between them, which means the friction over here between the surfaces is pulling the lower block. You see, it's pulling the lower block, which means friction can also pull. So you see, the relative motion between two surfaces decides whether it is static friction or kinetic friction. And when you have static friction, which means two things moving together, then the friction is of pulling nature. This is a heuristic. You could bring to me situations where this is not true. Static friction tries to pull the objects together, and kinetic friction tries to oppose or tries to stop the relative motion between two surfaces. If you have some doubts and you would like to discuss this one-on-one with me, you can click on the link in the description box or in the pinned comment.